Yes, good evening, students. We want to spend a few minutes looking at how to use the identity matrix to find the inverse of a matrix. And just for reminders, we know that an identity matrix looks something like this, where the leading diagonal is 1. The two digits are 1, and the remaining digits are 0. And this is a 2 by 2 identity matrix, right? But suppose we have a situation like this where we have a matrix, let's call this A, and we want to prove that A, B, C, D is the inverse matrix. So we're going to label that as A to the minus 1, which is a symbol for inverse matrices, right? If this turns out to be the inverse of this, then when we multiply this out, we should get the identity matrix, right? But before we do that, we'd have to use the process of simultaneous equations to solve for A, B, C, and D, right? So this will be a revision for quite a few students. But for those students who have not yet done this, this is going to be brand new to you. All right, so let's go. So we're going to group the A's together. We're going to multiply this row by this and this row by this so that we can get the A's together. So we're going to have 2A, 2 times A plus 5 times C, which is 5C. And that's going to give us what? That's going to give us 1. And this is going to be our first equation, right? Now let's multiply this row by this again. So 3A plus 8C, and that's going to be equal to 0. And this is equation 2, right? Over here now we're going to have we're going to do the same thing, but this time we're going to use this column. So we're going to have 2B plus 5D is equal to 0. So we're going to have 2B plus 5D is equal to 0. And this is our third equation. And we're going to have this multiplied by this now. We're going to have 3B plus 8D is going to be equal to 1. And this is our fourth equation. Okay, so let's work with this first pair of equations. We can eliminate C, the variable, and it's easier to eliminate A. So what we're going to do, we're going to multiply the first equation by 3 and multiply the second equation by 2, because we want the LCM for 3 and 2 is 6, and we want these two to become 6A, right? So the first equation will look something like this: 6A multiplying everything by 3, 6A plus 15C is equal to 3 ones 3, and this is going to be now 2 times 3A, 6A, 2 times 8C is going to be 16C, and 2 times 0 is 0. So from here now we can subtract the bottom from the top to eliminate this, right? So 0 from 3 is 3. 15C minus 16C, that's going to equal to minus C. And this from this is really 0. So if minus C is equal to 3, then C is equal to minus 3. So we'd have gotten our first value for C. Sorry for the sorry about the blur. Okay, so let's go over here now. We're going to do something similar over here now. we're going to multiply the top by 3 and the bottom one by 2. And when we do that, the first equation is going to be 6b. 3 times 5d is 15d. And that's going to be equal to 0. Right? And of course, 2 times 3b is 6b again. 2 times 8d is 16d. And 2 times 1 is equal to 2. Likewise, we're going to do the same thing. We're going to eliminate the b by subtraction. But this time we're going to subtract the top equation from the bottom. So 0 from 2 is 2. 15d from 16d is d. And 6b from 6b leaves 0. We could have done it the other way now. We could have subtracted the bottom from the top and would have ended up with some minus values, which would result in the same value for d, but this was the easier way. The top from the bottom was the easier way. So now that we have d is equal to 2, what we're going to do now, we're going to sub the c value. Sub c value into equation 1 to find a. To find the a value, right? To find a. So we're going to be doing that now. The first equation was 2a plus 5c. 2a plus, and anywhere c is, we're going to put the minus 3 there, is equal to 1. This now becomes 2a minus 15 is equal to 1. And of course 2a is going to be equal to 16, because when we transfer the minus 15 over the equation symbol, it becomes positive. A positive 1 and a positive 15 equals to 16, right? So a is going to be equal to what now? A is going to be equal to 8. So we have found the a value as 8. We're going to do the same thing for this equation. We're going to sub d value into equation 3 to find the b value. So we're going to substitute the d value into 3 to find the b value. So let's do that now. So we're going to go back to 2b plus 5, and the d is 2, and the way the d's we're going to put 2, and that's equal to what? That's going to be equal to 0, right? So 2b plus 10 is equal to 0, and therefore 2b is going to be equal to minus 10. When you transfer the 10 across, it becomes negative, and b becomes negative 5. So it looks as if we have actually calculated all the letters for the all the values for the letters. So we can now rewrite the equation as 2538. Yes, 2538 times a is equal to 8, b is equal to minus 5, c is equal to minus 3, and d is equal to 2. So what we really want to show is that if we multiply out a1, a to the negative 1, if we multiply it by a, we should get the identity matrix. So let's do that. All right, let's prove that. 2 times 8 is 16. So we're going to get let's draw a bigger matrix, right, for this. So 2, 8, 16. 5, 3 is 15, that's minus 15. That's for the first value. 2, negative 5, that's negative 10. And 5 times 2, that's a positive 10. So this is going to be reflecting a 0. Over here now we have 3 8s 24 and 8 3s 24. So it's going to be 24 minus 24, and 3 5 is negative 15, and 8 2s is 16, so we have a plus 16 here. So it does turn out to be the identity matrix. So 16 minus 15 is 1. This works out to be 0. This works out to be 0. And this works out to be 1. So in actual fact, this inverse was a true inverse for the matrix A. And that is how we can use this identity matrix to find the inverse matrix. Remember to like and subscribe to the videos on this channel, and I trust that you learned something and that you will share the videos as well. Thank you very much for watching. All right.